Before we finish the actual project and write the final code for this, we're going to look at some follow-up questions. The first is the finite state machine provided a mealy or a Moore state machine? Well, if we look at our state diagram right here, what we have is a Moore, and that is because we don't have user input. Mealy has user input, a Moore is kind of in case like this in itself. We do have a reset, but that is about it, and that's how I like to think about it. Then we're asked what changes could be implemented to improve our design. Well, what if we didn't have this stop right here, and instead we just went straight to our north-south pass, because we have an east-west stop as well, right? If we transition from the east to west, instead of doing an all stop, we went here. I might be looking at that a little bit wrong, but I believe you could maybe take this out and maybe this one out as well. That way we would transition, we're going north-south pass, so it's at green, then it's at yellow, and then it is going to go to red at this north-south stop, right? So why do we need this east-west state? East-west state was already stopped here. So my thought is that we wouldn't need this or this state. It's asking us what state is redundant, so possibly those two states, and how we could modify the FSM to reduce the state. We would just remove these, and the timer is still equal to 5 would just go to this one. Now we're asked to think about how we could use interrupts in a finite state machine. How could your finite state machine benefit from an interrupt? Well, an interrupt will be good when we want to hold it at a green light, right? So we play our code, we run our code, and then we interrupt it so it doesn't run any farther. And then we want to just stop it there so that our other light can pass. And so that is it for that. Now we're going to look at changing our code. So for the practical exercise, we are going to modify the finite state machine provided above to make the north-south road traffic light green only when a switch is pressed. So our north-south road traffic light is the one closest to our circuit, the actual part, the Nucleo 32. It's closest farthest to the left. And we made this on our breadboard in the previous videos in the playlist link below the like button. So this means that the east-west road will remain green, allowing traffic until a car arrives on the north-south road. Once that happens, we're going to press the switch, which acts as a pressure plate realistically underneath the roads, which makes the east-west road go from green to yellow to red, and then it's going to stay at red, while the north-south road is going to go from green to let the car pass to yellow to red. And so we're going to want to code that. Well, how do we do this? We have this while loop in our code right here, which we previously went over in the last video. And so we want this transition to the next state. How a switch statement works, it's very basic. It's like how it works in other languages, where we have a next state in here, and then we're going to compare it against these cases. So when we have our cases in here, I indented some of them, we're going to want to code for our states. So the transition NS state is the transition north-south state. So our next state, we can set it to the next state, which is the transition north-south handler. So it's going to go there. And then we have our next state right here, the north-south pass, east-west stop state. And so our north-south pass, east-west stop state is right here. And so the next thing that we're going to set it to, the next state, the next state is going to be the north-south pass handler. So instead of transition, we're going to the instead of like transitioning, we will be going to the north-south pass handler. And then we have an all-stop east-west state. In the all-stop east-west state, we'll just indent it here. We have it at the top right here. So this is our all-stop east-west state. We can see where it's going to. It's going to the all-stop east-west handler. And then the same thing for the next one. We have our north-south stop east-west pass state. It's going to the east-west pass handler. And then we have this next one where the transition east-west state, we're going to go to the transition east-west handler. And then all-stop north-south state, we're going to go to the all-stop north-south state handler. So we are going to each of these things right here where we have our north-south state, we're going to go to the north-south handler. If it's east-west, we are going to, just because it says it's a north-south east-west, we're going to go to the north-south. And then we can see that we have our east-west one here, so it's east-west, 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 east-west. And so the code is kind of bind it together. And then we have this default state where we set the next state to the all-stop north-south handler. and that is just going to all stop all of this right here. And so if we are to look at this, we can really tie everything together, especially if we look very closely. Like for example, the all stop north-south state is up, I think it's this one right here, all stop north-south. We would be sending it to the all stop north-south handler because it's going to handle that. But now we want to have a breakpoint, right? So we want three things to run. We want it to go from where we want it to stay at green, right? That's the only thing we want to run. And then we want to hit an if statement, basically saying if our button is pressed, do this. If not, well, don't do anything. So which one is this going to be? Well, it should be the case where we have the north-south, east-west pass state. So it should be this one right here. Inside of here, we're going to modify our code. And the reason why it's the north-south, east-west pass state is because this is where our transition would be, right? So the north-south is at the stop. So north-south is at red light. East-west is now at the green light. And so with it at red, this at green, we want to check our condition. So if our button is pressed, we're going to go to the next state. We're going to set our next state equal to the transition to our east-west state. Otherwise, we are going to stay in our same state. And we're going to use the code that we've previously looked at, and this is in the other part, part 1. And we have this if statement here. So we're going to use this if statement to read the pin. If the HAL GPIO read pin is red, we're going to be inside of here. That's all we need from that. So in this case statement, we're going to paste this. If our pin is red, we are going to be inside of here. So we want to check the state of our push button. We are going to set our E next state, and it's going to be equal to the next state. So what is the next state? Well, if we look at here, we want to transition to the east-west state, right? That's what we want to set the next thing to be. So we're going to do a transition underscore east-west underscore state. That should not be in caps, only the first part. So only transition, or only the T and the S in transition and state, and the EW should be capitalized. And that's it for our if statement. Otherwise, we want to stay in the same state. So we are going to take this E next state, I'll just copy and paste it in here, and we want it to be set equal to the same state. So we're going to set it just like this. I'll make sure you have your semicolon at the very end. And then we want to get rid of this, right? Because we don't need to, if we run our if and or we run our else statement, that's all we want to run, right? We either want to go to the next state or we want to stay in the same state. Well, if we do these, right, we choose one of these, well, we're still going to run this, okay? And we don't want it to go to the east-west pass handler. We want it to go in this code. So we can comment this out. Now, this is not the only place where we can write this code and modify it. If we are to scroll up into where we had our system states here, and we go into the actual event, so the east-west pass handler, that is what we were looking at. We want to see the east-west, which is the transition. That's going to be handling this. So the east-west pass handler actually handles our transitions. So inside of here, what we're going to want to do is we are going to, underneath our last delay, and this should actually be set to 2, I just realized. So the 5s should be set to 2s, and our 5s should be set to 1s as we've done here, and our actual 10s should be set to 2s. That way we just have a shorter delay. But for a stoplight, you probably want a longer delay than that. So once these are all set, we fixed that little issue. We are going to be inside of our transition east-west pass handler, which is going to be this one. And again, we want to be right underneath our last delay. And we're going to basically have the same thing. We have an if-else statement. And what we're going to want to do, I'll just copy and paste this in. It's basically going to be the same thing. We're going to check the state of our push button, return this next state, or do that. If we run this code, we're going to want to remove this return because we already returned something else, just as we did with our while loop and our statement inside of it, which is right here. So we remove this next state, and we have this code inside of here. Once this is all done, this code is the important part. We can either put it in here, or up there. We're going to want to control save this, or we're going to want to go to project. We want to go to build project, and it'll build our project for us. And we do have 2 errors, so let's look at this. I'm not sure what that error was, but what I did to get rid of it for now, after much trying, is and again we added this because it is necessary in your code, so don't delete that. I went and I cleaned out the project. Now we're going to go and build the project again. We're going to now try to run it. And so whenever we have errors like this, we're going to want to definitely clean out our project. So there is one thing we have forgotten to do, and that is to wire up our input, right? Because we're using the input, but what we haven't done is actually wired it up yet. And so what I'm going to want to do is I'm going to look at the pinout for this, right? And I've wired it to D13. That is where our push button is going into. So that's going to be PB3. So we'll find PB3, and we're going to mark it as our input, like that. Now from here, we can save this. We're going to click yes to generating our code. We want to open this perspective. Now this should copy over our old code and not overwrite it or anything. It's just going to add in our pin. So that is how that is going to look. We can go to project, build project again because we've made a change to it. We're going to click run. We're going to do a debug configuration. We want, of course, our 2.2 debug. We'll click debug, and it is going to download successfully. It's waiting for a debug connection, and it's going to switch our perspective. And so from here, it stopped right here. Our LEDs, none of them should be lit, and none of them should be cycling through now. So from here, and I know we've done a lot, so if you need to go back and rewatch it, that's totally fine. But none of our LEDs should be cycling on right now. If we even push the button, nothing should happen, right? We should have an indicator that our button is being pressed, but nothing should happen with our LEDs. What will happen is if we play this, some of our lights are going to go on, right? And it's just going to cycle through if we were at a previous cycle, and it's going to go to this green. So only this green light should be lit, and this red light should be lit. Basically, we're saying, well, the east-west path is green, so cars can flow, but the north-south is not passed, so cars will not flow. Now, if a car comes, we have to let it pass, right? So it's going to go over this button, which is acting as a pressure plate, and we can hold it, and we can see it cycles the lights down, holds it at red, and then we're going to go to green, yellow, red, and then we're going to go back to green. And it's going to hold it there and let the traffic flow through. Traffic wants to flow through the other way. We can press it, and it's going to cycle through, and it's going to go here, just like that. So we have a little traffic light working for us. And that is it for our code. All we've done from the previous video is we've added this code and commented out this code. We could add it into right here, inside of the actual transition to the east-west handler, because this is transitioning from the east-west, right? This is going to handle it, and that's setting all of our pins, right? We can see that it is resetting some pins, it's going to light up other pins, and so on and so forth. But we can only use one or the other. I like it in the switch statement though, so that's how I'm going to do it. And anyways, we'll do it one more time, and we can see that registers our button in the actual building of this breadboard is in the playlist link below the like button. This is all lab 2 stuff, so it's pretty cool. We do have a part 1, and next we're going to have a part 3. But that is it for this part 2.